This video is going to review how to solve basic systems of linear equations. Now, there are many different methods that can be used to solve these systems. We are going to be focusing on what are usually the first two that you learn in an algebra class, called substitution and elimination. There are many other ways, as I said, including what are called matrix methods, and there's several different matrix methods you could possibly use. We aren't going to really learn about them right now, but there are other videos that you can look at to see those. Now, the idea of a system of equations is we are trying to look for values x and y that are going to work in both equations at the same time. And so to do that, we're going to have to play around with both equations and see what we can do. Well, in the substitution method, you pick one of your equations and you solve for one of your variables, and you plug that into the other variable. You substitute it into the other equation. And so in this case here, I'm going to choose the first equation is already solved for y. That makes this more convenient. I'm going to go ahead and plug that in where I see y below. So instead of it being x plus 2y equal to 7, it's going to be x plus 2, and then instead of y, 2x plus 1 equal to 7. Then we're going to go ahead and work this out here. X plus 4x plus 2 equals 7. 5x plus 2 is 7. 5x equal to 5. And we get x equal to 1. But remember, we are looking for points to satisfy these equations, which means we don't want just an x value here. We want a y and an x value. And so we're going to go ahead and go back to figure out our y. We're just going to take this x value and plug it back in. Now you have complete freedom to plug it in either of the original equations, whichever is easier for you to solve for the other variable. I'm going to choose to plug it in the top equation. So instead of y equal to 2x plus 1, y equals 2 times 1 plus 1. So y is 3. And that means that my answer here is x is 1, y is 3. That is the point. Now I included a graph here because I wanted to show you what we are doing graphically, what it really means. So if I look at the first line, y equal to 2x plus 1, it's going to look something like this. And if I look at the other line, I have to do a little bit of work there to solve for it. Let me use green here. So if I solve for y in that, I would have negative 1/2 x plus 7/2. So that means I have a y-intercept of 3.5. And I go down 1/2 each time. The important thing, though, is that we see that the place where the two lines cross each other, that is the solution to our equation that we are finding here. So all the stuff that we're doing, solving these systems of equations, what we are really doing is we are finding the points where the two graphs cross each other. That's going to be very important when we look at nonlinear equations. Okay, so we have this good to go. We can look now at the second method, which is elimination. Now, the process of elimination is you are going to take your two equations and you are going to try to add or subtract them in some way that will cancel out one of the variables. Now, I chose this particular numbers here because it's going to cancel out the y very nicely. That won't always happen. Sometimes you might have to multiply an equation by 5 or something and then it'll cancel out. It's just a lot of playing around, and the more time you practice this, the better you get at figuring out what you should do to cancel something out here. But in this case, if I just add down here, I get 3x. The y's cancel, I get 6. Divide by 3, I get x equal to 2. Then I need to plug this in somewhere above to find my my y. I'll go ahead and choose that one there. So instead of 2x plus y is 5, it's going to be 2 times 2 plus y is 5. That gets me 4 plus y is 5, so y is 1, which gives me my final answer here of x is 2 and y is 1. So this was just a quick reminder about these two methods and how they work. You can use these same methods if you have 3 equations and 3 variables, or 4 equations and 4 variables. It just makes the problems take longer. But this is what we're doing here.